Hey folks, so you were tasked with looking up what a PC from the year 2000 would have been like in terms of specifications, and then comparing that to an average PC of today. So let me plug in some numbers here for you that I came up with. So the year 2000 actually was the year that I was a freshman in college, so I built my own computer, and it had a 233 megahertz processor and 128 megabytes of RAM. Now, this was a pretty decent computer for 1999, 2000. So we'll compare it to, I guess, what I'm still using today. So today I've got a Core i7 that runs at 2.2 gigahertz, and I'm running 16 gigabytes of RAM. Now, if we're going to compare megahertz to gigahertz, we need to translate this, right? What is 2.2 gigahertz and megahertz? Same thing down here, megabytes and gigabytes. We need to translate that as well. So to make these even, 2.2 gigahertz is equivalent to 2200 megahertz. So now you can see that these are, because they're using the same value of megahertz, we can multiply or divide these pretty easily. So just for easy, quick math's sake, 233 versus 2200, this is about 10 times faster. Maybe not quite as much, but of course there are plenty of other processors out there that run 3 gigahertz or more. Let's do the same thing with RAM. 128 megabytes, 16 gigabytes. Well, in order to translate gigabytes, this is actually 16,000, technically 16,384 megabytes. Now, this is a change of 128. So that's a pretty big difference. The CPU speed only grew 10 times in 20 years, but the RAM, at least RAM size, grew 128 times. So what accounts for this difference? Why did these grow at such large rates, or such different rates? Well, the CPU, this is the speed of the CPU here is not the whole story. There's a lot of other things going on that determine how much actual work a CPU can do. So let's take cores into account. This 233 megahertz processor only had a single core. My current one has 4 cores, and each one of those cores is dual-threaded for a grand total of roughly 8 times the amount of work. So actually, let's take this 10 times and make it 80 times based on core. Now again, that's still not the whole story either. We have differences in CPU cache. We have differences in the speed at which the CPU can fetch things from RAM. There are differences in the program and reprogrammability, the instruction set of the processor, making new processors much more efficient. So actually, let's double that again just for those things alone, and we might say that a modern processor is about 160 times faster. Now, these numbers are very changeable, right? If we had gone with a lower version here and a higher version here, we might be 1,000 times faster. So we're just kind of looking for rough averages here, right? It's not that a computer today is twice as fast, it's way faster. It's hugely faster than it was 20 years ago. RAM suffers some of the same thing, 128 times the capacity of RAM, but RAM has also gotten better. It's gotten faster, for one thing. The density of the chip can make a difference as well. So 128 times the RAM is just the capacity. If we look in terms of the speed of the RAM, the performance of the RAM overall, we probably go up, and maybe it's 200 times faster. So what we're saying then is overall, a computer today is maybe 200 times better than it was 20 years ago. We could do the same thing with the hard drive. How much hard drive space were we putting in an average computer then? How much in an average computer now? So all of these give you a picture of how fast things change in the computer industry, at least in the PC hardware industry. So let's look forward. Can we expect this kind of change again in 20 years? So if a computer is, let's say on average, about 200 times faster than it was 20 years ago, in the year 2040, will it be 200 times faster than it is today? In the year 2060, will it be 200 times faster than that? At some point, we're going to have to change technology. Silicon on a chip has its limits. Moore's law states that every 18 months to 2 years, the transistors on an integrated circuit double on average. But eventually we hit a physical limit. We can only make things so small before we're getting down to some real physical challenges. So keep that in mind when answering that question. Will computers be this fast? Will we expect this kind of change 20 more years into the future?